Hello everyone. Today we are solving an example on Bayesian network. In this we are given some questions of inference and we have to find the probabilities. Okay. The inference question will be like the x given E is the evidence and x is a query variable. Okay. So I am taking this example: cloudy, sprinkler, rain and wet grass. Here cloud is independent, sprinkler and rain is dependent on cloudy, and wet grass is dependent on sprinkler and rain. As you all know, the Bayesian network is a directed acyclic graph. So let's start solving. So as you all know, this is a directed acyclic graph. Sprinkler and rain both are dependent on cloud, and wet grass is dependent on sprinkler and rain, as you can see the arrows. So the solving this type of inference questions, first you have to find the total probabilities of each types, means like total probability of cloud, total probabilities of sprinkler, total probabilities of rain, and total probabilities of wet grass. Okay. So today I will show you how to find the total probabilities. Now see, cloudy, it is not dependent on any previous things, so it is its total probability, like cloudy is true is 0.5 and cloudy is false is 0.5. Okay. Now sprinkler is dependent on cloudy, and this table indicates sprinkler is true when cloudy is true is 0.1, sprinkler is false when cloudy is true 0.9. Same as sprinkler is true when cloudy is false 0.5 and sprinkler is false and cloud is false 0.5. These are not the total probabilities. We have to find the total probabilities like this for sprinkler, rain and wet grass. Then only we can solve further questions. Okay. So I am showing you how to find the total probabilities. Total probabilities. Okay. Now see, for sprinkler, as you know, in this, if it is like we are showing true and false, so we can use this also, P of R, and this is negation, as you know. Okay. So I am using this type of convention. Now P of, I am finding the total probability of sprinkler, P of S. P of S. Now see, sprinkler is dependent on cloudy, means we have to take both the conditions of cloudy. Cloud is true as well as cloud is false also. Okay. So now see how sprinkler given cloudy is true into cloudy plus sprinkler given cloudy is false and cloudy is false. We have to find in this way. Okay. Now see, as given C is true, and here I have not used any negation, means I am assuming S is also true. So S is true, C is true, it is 0.1, 0.1, P of C is 0.5, 0.5, same as S given negation of C, means S is true but C is false, negation, so it is 0.5, and P of negation C, which is given as 0.5. So I am here writing 0.5. If I will solve, I will get is a 0.3. P of S. P of S means P of S equals to T. True. So what will be P of negation S, means S equals to F, means 0.7. Because positive plus negative, this probability will be 1. Total probability. Okay. Same we have to find it for rain. Now see, for rain, P of R. Rain is also dependent on cloudy like sprinkler, so P of R C into P of C plus P of R negation C into P of negation C. Okay, now C negation C into C. So P of R given C, R is 2 and C is also 2. Here in this R is 2 and C is also 2, it's 0.8 into P of C is 0.5 plus R given negation C 0.2 into 0.5, it is on solving we get 0.5 P of R. Therefore P of negation R is 0.5 only. Okay, this is the total probabilities. Now for wet grass. Now see, wet grass is dependent on sprinkler as well as rain. So now when I will find the total probability, I have to consider both the cases. Okay, so see how I am considering wet grass. W, what I will say, W is on sprinkler and rain. So both are true, and probabilities are also in multiplication. Plus W is true but sprinkler is true, I am taking and rain as false. One combination means true false. So it will also P of S into this negation R, same as P of W negation S R, P of negation S R. Plus now see S2 R true false true. Now there is false, so P of W negation S negation R into P of negation S comma negation R. Now see, we will get these values very easily from the table, but these values, see, I'm writing one step more, P of W S comma R. Now see, S and R both are independent of each other, means they sprinkler is dependent on cloudy and rain is also dependent on cloudy, that's not an issue, but they don't have any connection in between, so they are independent. So in this the probabilities we writing as P of S into P of R separately. Same for this, P of W S in R into P of S into P of negation R, same P of W S R, P of negation S into P of R, and same as P of W given negation S negation R, P of negation S into P of negation R. Okay, in this way we have written. Now we will substitute the values. Now see, I am marking this as a bracket, so it will be very easy. These are the plus signs. Okay, now see, W given S and R both are true. W is true, S and R both are true. 0.99, 0.99 into, it will be 0.3 into 0.7, 0.5, sorry, 0.5. Same as this, it will be 0.9. I am taking from the tables, 0.9 into 0.3 into 0.5. Now see, W given S is true, R is false. W is true, S is true, R is false. Is 0.9, I have taken here 0.9. And what is this? P of S and P of negation R. P of S is 0.3, I have taken 0.3. P of negation R, P of negation is 0.5, I have taken 0.5 here. Since wet grass is dependent on sprinkler and rain, that's why we are using these values also. That's why I found these values first. Okay, now plus 0.9 into 0.7 into 0.5. This will come like this. And now for this, w is true and both are false. W is true, both are false. It's 0 into zero point 0.7 into 0.5. Both are false, so 0.7, 0.5 is coming. This term will get 0. So at last, when I will do all the summations and all, I will get a 0.5985. Okay, so I am writing all the total probabilities here. P of S is 0.3, P of negation S is 0.7, P of R is 0.5, P of negation R is 0.5, P of W is 0.5985, and P of negation W is 0.4015. What it indicates? W and negation W. As I told you again, I am saying W means W equals to T and negation W means W equals to F. Okay. In this way, we have found the total probabilities. In this way, you have to find the total probabilities of these values. On the next video, we will solve some examples on it, so it will be very clear how these total probabilities will be used along with this table values too for the inference questions. Thank you.